This video will provide you with a detailed demonstration of the wiring steps for the BMS. In just 5 minutes, you can install the BMS on the lithium battery of the electric bicycle. This BMS has a dedicated and compact appearance, 61.7mm in length, 34.7mm in width, and 9.3mm in thickness. The BMS stands approximately 0.5cm shorter than the 18650 battery. The width is less than the thickness of the 2 battery cells, and the BMS itself is also very thin. So installing such a BMS for the entire lithium battery, the space occupied is very small. This is a set of 10 strands 4 parallel lithium batteries, and that is a set of 36 volts 10 amp power batteries. We use 18650 type battery cells, a 10 lithium battery with a single capacity of 2500 mAh. When assembling batteries, to plan the overall negative electrode position of the battery in advance, convenient welding with a B wire when installing the BMS. Before welding the wiring, first use poly paper to insulate the battery pack. Then add an exposed board on both sides of the terminal. Perform further insulation treatment. Mark B0 on the total negative electrode of battery. The connection between the first positive pole and the second negative pole is marked B1. Then mark B2, B3, B4, etc. in sequence, until the total positive electrode is B10. Next, let's plane the location of the BMS first. Plane the location and direction of BMS cables again. Add tin to each terminal for easy soldering and wiring. The first black flat cable corresponds to the total negative pole B0 of the battery. Next to the first red one corresponds to B1 and the second one corresponds to B2. Continue until the last cable corresponds to B10. Cut out the excess part of the cable. Cut out the wire core with wire pliers. Next, we will start welding the cables. Do not insert BMS during the welding process. Also, be careful not to cause short circuits. The wiring welding is completed. Let's have a test about whether the connection is correct. First, set the multimeter to the voltage range. Measure the voltage between adjacent flat wires. When measuring the cable layout, do not touch the 2 terminals of the multimeter together to avoid short circuits. The voltage between the cables is around the nominal voltage. Verify that the wiring is correct. You can also use a detection light board or a cable detector. Check if the wiring of the cable is correct. Apply hot melt adhesive to the flat cable and strengthen the fixed section again. Next, you can plug in the BMS. Position and secure the BMS properly. Next, we will weld the B wire of the BMS to the total negative electrode of the battery. Connect the positive output wire at the main positive electrode. Convenient for later docking to the output line of the battery box. The total positive output line has been welded. Insulate the terminals to prevent short circuits when accidentally touching the negative electrode. Next, we will test whether the BMS is working properly. Method 1. The total voltage of the battery without BMS is the voltage between the total positive and negative terminals of the battery pack. Retest the total voltage of the BMS. Is the voltage between the total positive pole of the battery pack and the black P wire. The 2 voltages are equal, indicating that the BMS is working properly. Method 2. Measure conductivity. Set the multimeter to the internal resistance range. Test the internal resistance between BMS BY and PY. The internal resistance is 0 ohms and has been connected. The BMS is working properly. The BMS has been installed and is working properly. So, how reliable is the BMS? The BMS has functions such as overcharging, over-discharging, overcurrent, and short-circuit protection for a battery. We take the most stringent short-circuit protection as example to measure the performance of the BMS. Why is short-circuit protection the most stringent? At the moment of the short circuit, a very large current is generated. BMS with poor quality will directly burn out, causing the battery to also be scrapped. So, what will be the performance of a DALY BMS? Before measuring short-circuit protection, let's first take a look at the voltage between the positive and negative terminals. As can be seen, the voltage is 39 volts. Next, we will start conducting short-circuit testing. Directly short-circuit the positive and negative terminals. Let's see if the BMS has activated the short-circuit protection function. At this point, the voltage between the total positive electrode battery and the BMS PY is 0. The BMS has disconnected the MOS tube. The total positive and negative voltage of the battery is still 39 volts, indicating that the battery is functioning properly. We separate the positive and negative terminals and disconnect the short circuit. As you can see, the voltage has returned to 39 volts. The BMS has automatically resumed normal operation. Short circuit protection test successful. Install a high-quality BMS for lithium batteries, which can last for several years.